Okay, David, so we are already gathered all of our attendees, and I think that we can start, and the stage is yours.
All right, well, let's get started. Hopefully everybody has coffee. I know I do. And it's 9 o'clock in the morning here on the East Coast of the United States. So I'm just starting my day, and I think already you're getting ready to wrap yours up. So hopefully I won't bore you. Okay, so my name is David Makogon. I work for Microsoft. I'm in the same group as Alexei, and we are Azure guys. That's what we do. We eat, sleep, breathe, and work with Microsoft Azure all the time. And so today I'm combining two topics. So it's going to be a fun-filled session. We're going to have a little bit of fun with this. There's something called mobile services in Azure, and there's a lot of buzz around NoSQL databases, which is basically not your average SQL Server, MySQL, Postgres type of database. We're going to smush them together. So let's just take a quick look. This is my agenda. Wait till you find out that I really don't have any slides. This is very demo-oriented. So let's just rip right through this. And I'm assuming you can see my slides on my desktop, right?
Yeah.
All good? Okay.
Yeah.
So we're going to take a look at the magic of mobile services. But what mobile services is, just raise your hand, and I can't see this, but raise your hand if you've thought about building a mobile application, whether that is on an iPhone or Android or Windows Phone or a Windows tablet. If mobile is even of slightest interest to you, and it should be, every hand should be up, because the world, right? My hand is up. The world is moving toward mobile. When you look on the bus and you look on the train and you look around a meeting that you're in, you will see people on their mobile devices. That is where energy is being spent and people are living. So imagine you have the great idea to build a mobile app, but you need somewhere to store your data. You need somewhere to manage your API and to scale as your traffic grows and to deal with login identity like Google or Facebook. You need to do all of these things. Now in the old days, we had to build all of that stuff on our own. And we would spend hours, days, weeks building our infrastructure just to support an app. Along comes mobile services, and now we're taking it to the next level. So when you look at Azure and the type of services it offers, what we're trying to do is simplify your life. Let you get on with building your mobile app and being the next Instagram or the next Facebook, and focus on your app and not worry about what's going on behind the scenes with the plumbing. I'm assuming that throughout the day of the bootcamp, you've seen virtual machines or cloud services or networks, and you've seen just how much plumbing and infrastructure is taken care of for you. So you could just spend your time building your app. Mobile services is exactly that. That's what we're trying to do, is simplify your life. So you could build the app. The other thing I like to think about is, I call cloud, people call it software as a service, infrastructure as a service. I say it's what if as a service. I wake up in the middle of the night with a great idea. What if I try this idea? So I just want to build a quick app, see if it works. If it is, start a new company. If it's not, delete it and go to sleep. Well, mobile services helps me with my dream of what if as a service, because I can quickly try things out and build my app immediately. So that's the idea of mobile services. And by default, mobile services uses SQL Server or our SQL database service as its back-end storage. So if you're building a to-do application, like a task list, it might have a table with the text of your task and whether things are complete. And then you can even modify the way the behavior works in mobile services by working with server-side scripts. Today we supply support for both JavaScript which is in production, and .NET or C#, which is in preview. And if you're not happy with the columns you get, you can easily add your own columns. So if we were to take a look at the portal, the Azure portal, I'm going to assume that everybody today has seen the portal all day long. And this is not a mystery at all what the portal is, right? Can I assume that that's correct? Right? Somebody acknowledge?
Yeah, you're correct, but we're just mute our microphone because there are some echo, so that's why mostly we will do the listening.
Okay, feel free to chat in the window just to give me an update then, or if there's any questions.
Okay.
So we've seen then the portal, and as we look toward the left side of the portal, let me zoom in, open my screen all the way. We see this new thing called mobile services. And specifically, this new thing, whoops, it's not, I just have to do something here. Let me see if my little Zoom app works correctly. I seem to be having a technical glitch. Okay, so anyway, over here, mobile services. And this is yet again another service that Azure offers. And so if we wanted to create a new mobile service, it is, the screen is too big now. It is simple as creating it just like any of these other services that you would have created. So Global Windows Azure Bootcamp, David. And it really doesn't matter what you call it. And when you first build your mobile service, it's saying, how do we want to do this? It's assuming you want to use a SQL Server, which is really a great option if that happens to fit your data model. Now again, we allow you to do back-end programming in mobile services. Now why do we do that? In your mobile app, typically, what are you doing with the user? You're showing the user something, or you're letting them enter something. I don't know if it's a to-do list, or if it's a bus route tracking, where you want to see which bus to take to work. It doesn't matter what you're building. It could be a Foursquare where you're checking in. But do you really want to bury all this fancy logic on your mobile app, or do you want to treat it like any other app we've been building in the past few years and put all your logic on the server? So that's really what we want to do, is build that server-side logic. And like I said, by default, we take one of my SQL as a service servers. This is really very, very simple. And what we do, just to help you get started, is we build out a structure for you so that you can quickly start building an application. Now, what's really neat about the applications that we let you construct is we don't care what mobile device you're targeting. We don't care what client-side frameworks you're targeting. This is completely up to you. And one of the messages we strongly tried to get across this week when we changed the name of Windows Azure to Microsoft Azure is that it's not just about Windows, that Azure itself is really a utility for you to take advantage of. It's a cloud utility. And if we take a look at what this has created for us, we have our mobile service, but I want you to pay attention to the platforms that we offer right out of the box. Yes, you can build a Windows Store app, and we want you to. Yes, you can build a Windows Phone 8 app, please do. But if you happen to be targeting other environments as well, we have native support for iOS and Android. We have HTML5 stack. And then we have the frameworks, these cross-platform frameworks like Xamarin, PhoneGap. So if you wanted to build the world's simplest of applications, you can. And now I'm demoing on a Windows machine right now, so I can't show you iOS right out of the box, but if I wanted to build, let's say, an HTML5 application, I could help get myself started. I could say, yes, let's build a new HTML app. Now, this thing here with creating a table, this is something for our convenience. This is a helper. By no means do you need to do this for your own commercial app, but in this case, we're saying, let's get you started. We're going to build a to-do application. We're just going to get you started. Now, before I click that, I just want to show you that if we click up here in the Data tab, we have absolutely no data. Just wanted you to see that. If we go back down and we say we're going to create a new app, and we create a table, what this is doing is constructing a table in SQL for us. And now we have our table. Hopefully you can all see that. And we have no data, but we could browse the data. Now this is kind of interesting that mobile services has all of these online tools to show us what our data looks like. This is a super convenient tool, but again, it's all circling around SQL. It's making a big assumption that we want to use SQL Server and SQL relational data in our mobile service, which is absolutely fine if that's what you're interested in. So again, we go back, we've created our table. Now we can download a starter app, which is a very, very simple to-do application. Now I'll go ahead and save this. And I know you can't see my saving here, so we'll just store it here in my wonderful folder. Let's extract it just to take a look at what we have. Boy, it really hurts when you have multiple monitors, because it's open windows on every screen. So if we take a look, all we have is this server, an index, right? Very, very simple stuff. Hopefully you can all see that. Okay. So now if we take a look at the instructions of what it was telling us, it says once you have your files, then on Windows, go into the server directory, run this server script, and visit our local host just to see what everything looks like. So let's open a command window to our server folder and see what we have. So we could say, oh, actually, I guess we could run that from, let's see if it'll run here. Launch Windows. And it looks like, what is this saying? Do I want to trust? Do I want to run? Yes. Yes. Run only scripts. Do I want to run? Alt is D. Do I run? Hold on a second. Let me redo this with a little bit of trust, because it seems to be ignoring me. There we go. I had to hit R for run. Okay, so IIS Express is running. Now, if we open a browser to localhost 8000, which is our server. Again. All right, so this is our brand new mobile services app that we just built. And we should be able to say something like, wake up for GWAB and add. Now if we go back to our mobile services window and take a look at data, look at that. I know you're all applauding right now because you're just so excited here. So what you've seen is very, very simple, that we have built an application that's talking to a back end. I could have built a Windows Store app. I really could have built anything I wanted. And if I wanted to do something custom, like when somebody inserts a row, like I just inserted something, I could have run some JavaScript. I could put custom code for an update. I could put custom code when somebody deletes. And what do I mean by custom code? I could filter data. If you know how to work with JavaScript and Node.js, you can pretty much put anything you want here. Maybe you want to block deletion. Maybe you want to log the deletion in another database. Okay? You have full power to do anything you want here. If you want to customize the data, look at this. We can add a column. This is very, very simple stuff. And you can also worry about permissions for who can do something with an insert or an update, etc. So hopefully that makes sense and you get a feel for what you can do with mobile services. And certainly we could easily demo, downloading, say, a Windows Store app. We already have the table, and if we wanted to download a Windows Store app, it's pre-configured with the key of the mobile service, and it would really be an effortless thing to download this and run a mobile app that does the exact same thing. So I'll just start it downloading in case we're interested in looking at that. We're going to look at that later, but I know we might be pressed for time a little bit, so I want to make sure we're able to get through everything that we need. Before I continue, I just wanted to see if there were any particular questions anyone had. Because I know you guys have the microphone muted, so I just wanted to double check and see if there's any questions up till now. I don't want to be the only one talking. Unless you want me to be the only one talking.
Yeah, David, so basically we have several questions, but I think that it will be better if we just write it down, and at the end we will ask you all those questions. Or
okay.
to ask it right now.
Well, either way, I just wanted to make sure that what I'm presenting is making sense.
Yes.
Because I can't see any heads nodding, I can't get a feel for we're doing okay here.
No, it's making sense, and we are creating this list of questions. So you can continue, and at the end we will ask you all those questions. So if you're okay with it, then we're okay with it also.
Okay, well, fair enough. Okay, so I fixed my little pointer issue. Yeah, I can go on the screen today. Okay, so basically, I've shown you some of the basics of mobile services. Now, to-do lists, or maybe we did 5-7 years ago, and you were the first person to ever build a to-do list app, and you made your million, and then nobody else does. Now, of course, you're going to build the world's greatest application, and this greatest application is going to take off because you will advertise it, and you will show up on TechCrunch, and you will show up on Reddit, and you will become famous. Now, we have a free tier that all of you can start using today, right? It's really, really cheap. It's free. There are restrictions to the free tier, and if we go to Azure.com, we can see just how restricted that can be if you're building a real-world application. My idea here is not to talk about pricing. I just want to warn you that when you are testing, that there are certain limitations that you will have. So this you get completely for free. You can have up to 10 services running, and you can make 500,000 API calls with up to 500 devices. Now that's really, really good. But you might run into limits when you hit the big time. So you can always scale. And forget about the pricing. The point is you can scale to meet the needs and demands of your customers. And I think this is really important because it scales just like our other services. So if we go to standard, we can choose a schedule during the day. Maybe you want to, in the morning, scale up, and in the evening, scale down, or I should say scale out and in. We can use metrics, and we can say, I want to scale based on the number of API calls, and I want to scale anywhere from 1 to 10 instances. Why not? Right? We want to make this huge. Let's not worry about the database right now. But you can see that it's very, very easy to set up scaling, and I can handle just an absolutely enormous amount of traffic with mobile services. You can also set up identity management. We're not going to show that right now. This is a very simple exercise for you to go through, and we have it in our Azure training kit. But you can actually use Twitter and Google and Facebook and Azure Active Directory. You can use all of these for login purposes on your application, which removes you from managing credentials. And again, you've seen this theme probably with other services in Azure. This is all built in. We have push notifications. Again, we support Apple and Google right out of the box, and Windows. This is Windows Store and Windows Phone. So if you have a mobile app and let's say it's a location-aware app and you want to tell the user that your friends are nearby, well, fantastic. You could do a push notification, right down to their device, regardless of the device itself. Hopefully that makes sense. We also have something called scheduled tasks. So you could say, I want this task to run every hour in the background. So it's a very powerful platform, really, really powerful platform. Now, where I find the world getting very interesting is the story about data itself. Now, Alexei and I have talked numerous times about the data platform. In fact, I think in Poland a few months ago or 6 months ago, we had a talk about this thing called NoSQL. And in case folks aren't familiar with NoSQL, I just want to give the world's fastest crash course on that. And then we want to see if we can merge the two together. So if you think about data, as we talk about all these databases, there's always a database out there where you hear a name. There's SQL Server, there's MySQL, right? There's SQL Database as a Service, which we just saw with our mobile services. And then there's all these new names coming out. Hopefully you've heard of some of these, like MongoDB and Neo4j. What are these things? Fundamentally, they break down into two types of database, and these are broad categories. There's no magic behind these terms, but SQL means that they're database engines that have the SQL query language. That's fundamentally it. And we can add Postgres to that list, and we can add some of the embedded SQL engines, like SQLite, which is used in applications like Lightroom from Adobe, where you do photo management. Right? There's so many assortments. And then there's these NoSQL things, and they're just a little bit different. Not that they're better, but they're different, and they're for different purposes. And what do I mean by that? NoSQL databases, you hear these terms like schemaless. Now, what we're saying here is a SQL database usually enforces a schema. Out of the box, you have to have a table definition with columns in your table and restrictions on the columns, and every row in the database has to look the same. It's a bit different in the NoSQL world. While there's no such thing as no schema, NoSQL databases tend to be flexible on schema. If you have studied database theory, there's something called CAP theorem, where you have consistency of data, availability of your database, and tolerance as you partition your data. And then you get to choose any two. because you always have to sacrifice one of them. It's no different in the NoSQL world. We tend to cluster servers and we tend to scale out rather than up. If you've ever administered a SQL database, you typically build bigger computers. And in the NoSQL world, we typically add more computers. Now, I want to take a step back a second and say that, well, what are we even talking about NoSQL? Well, how many times have you ever built an application using SQL as your database store where you had to work really, really hard to come up with a solution because SQL wasn't very friendly to your solution? And what do I mean by that? Let's have an example where we're storing product information, like a catalog on an online site, like Amazon.com. So you're looking up information on a camera. What does a camera have? It has the body weight, the sensor size, what type of data card it takes, right? These are very specific to digital cameras. But then we look up something like, I don't know, a mouse. And the mouse is Bluetooth or USB. It has blue track. It has a trackball. Maybe it has a resolution and what kind of battery it takes. Now try and model that in a SQL database. What do we do in a SQL database? You start thinking about a table, and we have different columns in our table. And what are those columns? Maybe we store a special table just for mouses. And so here's our DPI, and here's our technology of Bluetooth versus USB. Now we have a camera. Do we make a separate table for camera data? Is that what we do as a smart SQL programmers? Well, no, because now we have to have one table per product. Okay, so maybe in SQL we have a property table, and this says, okay, for this product ID and this property name, we have a value. So this is for my camera, this is for data card type, and this is compact flash. This is for the mouse, this is technology, and now this is USB. You can imagine the challenges here as you try and search for all properties. You now have to have, what, an index here, you have to do text search on the properties. We've done this. If you're a SQL programmer, you've probably done this. And it works fine, but maybe it doesn't work the best. You're making a compromise because you're squeezing data in that's a little difficult. Now let's pick a different example. I'm going to assume you've seen websites like LinkedIn, a business website where we connect to different people in our industry, and then maybe I'm connected to Alexa, who's connected to the president of another company that I'm interested in talking to, so I can use my relationship there. And perhaps here's me, here's Alexa, and here's the president of that company. And so I am friends with Alexa, who's friends with the president of that company. So it's this nice relationship. This is a node, this is a node, this is a node, and these are relationships. How would I do that in a SQL database? How do I dream that up? How do I make it work? Well, it's a little bit challenging because I probably have to have a special table, right? We've done this before where we have like person ID, friend ID. And then we have to map that friend ID over here to the next friend. And you can imagine how complicated this could end up getting if we had to do a join on ourselves to find a relationship. And then do another join to go one level deeper. The problem I'm describing is not that you can't do it in SQL, but maybe there's a better engine that's built from the ground up to take care of this type of query, this type of relationship. And that's why we have the world of NoSQL. That's where it all came from, is people want to do things differently and not be boxed in. So we have 4 common types. We have what's called a key value store. This is Azure Table Storage. Did you guys look at Azure Table Storage today? If you did, okay, you haven't. So Azure Table Storage is just key value pairs, and it's just massive storage. And it doesn't enforce the schema. It's really great. Oh, you did. Okay, funny guys. Document storage. If you've heard of JSON, which is JavaScript Object Notation, what is JSON? It's key value pairs smushed together into multiple key value pairs in a group. That's a document. What's a graph? Remember I just showed you the LinkedIn example, nodes and relationships? There you go. Now you know what a graph database is. And column stores is almost like the way SQL works, where you store rows, but instead you flip it around and you say, for any given entity, or row if you will, I want to store a group of columns together. And I'm storing those together for high-speed performance. Maybe it's Twitter data, and you only want to know that the username and the tweet. And maybe you don't care about the GPS location, or the timestamp, or the app that they use. You just need those 2 fields. So the idea is to group data together. Now for table storage, we have Azure Tables. This is something to really look at to see if it fits in your applications. You basically break things down by a partition key and a row key, and those 2 keys together give a unique row or entity. We take care of this for you. It's storage as a service. We triple replicate the data, so every time you write to data, it's in 3 disks. We can then geo-replicate it to another data center. If a data center goes offline, we give you access read-only to the other data center. You can scale up to 200 terabytes, and we have SDKs for a half dozen languages. Very, very simple to use. So that's one instance. You also have Memcache and Redis. There's probably many other key value stores. So it's a very powerful type of solution. It's not the richest when it comes to query languages, but if it's discrete data, maybe you're storing tweets, maybe you're storing logging data, it is a brilliant solution. Now there's document database. We're going to pick on MongoDB for a minute, but I want to be clear, there are many document database engines out there. There's RavenDB, there's MongoDB, there's many others. Just spend a little time on Bing and you'll find them. The reason I'm picking on MongoDB is they are the most open in the community. They hold conferences everywhere. They have an amazing amount of data on their website. There is drivers for dozens of languages between .NET, Scala, Java, PHP, Python, Node, Ruby. You almost can't find a language they don't support. If you love querying with SQL Server, you'll love querying with MongoDB. They probably have one of the most powerful query engines I've ever seen. They have built-in MapReduce. They have an aggregation framework where you can aggregate data in the documents as you go. It's really a fantastic option to consider, and it is completely supported in Microsoft Azure. We have 2 hosting partners, at least that I know of, MongoLab and MongoHQ. MongoLab has dedicated clusters, free instances. You just start right now and get a half of a gigabyte for free. Their dedicated clusters run in every data center except for Japan right now, because we just launched those data centers. And we have instructions for how to install it on your own. This is a key element of Azure, that sometimes there's a service available to you, and if not, if you can install it in a virtual machine, away you go. And if you've seen virtual machines today, you know that you can attach hard disks to them, or virtual hard disks to a virtual machine, up to 2 disks per core. So if you have an 8-core machine, that's 16 disks, up to 1 terabyte per disk. That's quite a lot of data. and Linux or Windows support for MongoDB. And then there's a graph database. There are several graph databases out there, but the hottest one right now in the community is called Neo4j. It's an open source engine. They have both a free version and a paid version. There's no hoster that I know of that provides Neo4j as a service today, at least not in production and not in Azure, but that doesn't stop you from firing it up. It's all about nodes and relationships. As far as high availability, you can build a single node, you can build multiple nodes, it's very flexible. And they have a rich set of SDKs. They have their own query language called Cypher. Let me stop and ask if there's any fans of The Matrix in the room, the movie The Matrix. You want to assume there's at least one fan of The Matrix. And I'm going to assume that that one fan of The Matrix is looking at the name, saying Neo4j. Neo, I know that name. And then they're going to look at the language and pick up on Cypher. Yes, the guys at Neo Technology love The Matrix. Just wanted to point that out. You can easily install it on Windows and Linux. If you go to neo4j.org, they have an entire portal around cloud distributions and an entire sub-portal on Azure. In fact, they love Azure so much, they've been working with me for the past, a year, 18 months. We've been building images in VM Depot, and the latest image just got published a week ago. And I'll show you that in a moment. And finally, there's Cassandra, which is a column database, column family. You get to choose your level of consistency and availability. You partition it across many servers. You build massive clusters that can span data centers. They have MapReduce built in. They have lots of SDKs, and they have their own query language. And you can see that there's several database engines that we've seen in the wild where people are constructing compatible images for Azure. So let me just show you a little bit of what I mean with all these databases. I want to give you a sneak peek of Neo4j. Now, most people, when we talk about NoSQL, and most talks that I do, we're always talking about MongoDB. And obviously, it's the really amazing database. It's a document database. But given that we only have about 15 minutes, I want to give you a sneak peek at what a graph database looks like, the kind of things that you could do with a graph database, just to kind of pique your interest on it. And then I want to show you the merging of mobile services and NoSQL, because what you saw today is mobile services running with SQL, and I want to assure you that that is really just a starting point, and that the sky is the limit. Whatever you want to accomplish, you can. There's really no specific limits to what you can do. So having said that, I was just in India last week giving a talk in Bangalore, and so I do have my server still running. I would like to just, whoops, why does it do that? Try that again. I just want to show you my browser here and what this looks like. So this is the Neo4j browser. What's really awesome about Neo4j is when you install the server, for free, you get a web interface, which makes life so nice and so easy to start working with it. It really gives you a great launch point. So one thing that I have been doing is demoing a movie database. Now remember, things are all about nodes and relationships with Neo4j. So we have a node, and we draw in ASCII characters. We have a node, which then as a relationship of some name, which then goes to another node. Fundamentally, that's Neo4j. We draw our relationships. So we could say, match, this is a query statement where we want to basically do some type of operation. We want to search. Match is like a find. So maybe we want to find my movie name, which is just a temporary variable name. And maybe I want it, let's reverse the direction. Let's go this way. So we want to say there was a movie rated by a user. Now, in my database, I happen to have login names on my users. So before we do this match, let's see what kind of usernames we have. Let's say we want to match a user, and we have what are called labels in Neo4j, which are like node types. Or if you've used something like Google Mail, Gmail, you're able to label your mail, and you can have multiple labels on a given email. You could say this is an expense, this is a purchase, and you can have as many as you want. So I have a type of user. So let's match nodes that are users, and we will return the user.login. And I don't know, let's limit this to 5 and see what it brings back. So here I have a bunch of usernames. Now, unfortunately, we didn't find me. So we happen to know that there's a login property. So I could say for login of Makogon. Now notice I just created a JSON object as my search. Let's just return that user in its entirety. And there we go, there's my user. I can click on me, and I can see my login and my name. Now, I happen to have rated some movies, so I could say again, match user Makogon, and now I'm going to draw my query. I'm going to say, David rated a movie. And now the node type, again, is movie. We don't need to have labels, but it certainly speeds up our queries, because if I have a million nodes in the database, I don't want to search every node, only movie nodes. So now for the given user, David, let's take a look at this query, how simple it is. This is my node, separated by parentheses. Here we have a relationship. Notice we're just drawing the direction. Now we have my movie. So we're saying some user has rated some 1 or more or 0 or more movies. Let's just return the movie.title. So this right here is my collection of movies that I have reviewed. Hopefully that makes sense. This is very, very simple type of querying. Now, maybe I want to search for a movie. This is a type movie, and I want to say where movie.title equals Die Hard, and then return the movie, the entire movie node. And look at this, we have our description. And we have all sorts of details, like a picture of the movie cover, its action, right? So there's a property called genre. So maybe we want to say match movie where, now we could either do a where clause, we could say something like that, or there's a shortcut where we can simply say genre is action. There we go. You can do it either way. And let's take the shortcut and then say return movie.title. So now it's going through the whole database and returning a massive list of action movies. And we try to return too many. So let's just say limit 20. I think this is like 50,000 movies in this database. So you can see lots of action movies. Hopefully this is giving you a feel for the types of queries we can do. Now what we're going to do is we're going to have an application that I built along with my teammate that incorporates these types of queries into a back-end service in mobile services. Now, remember we just searched for Die Hard, and we just searched for movies that I reviewed. Now let's just try this one time here. Let's take a look at, let's do this. Match a movie that was reviewed or rated by David. Okay, we're just going to do a quick match on all of my movies and say return user and movie. So we're just going to take a look at that. And we'll even add a variable called rating. Because guess what? You can have properties on a node and you can have properties on a relationship. Oops, what did I do wrong? So here, now this is really cool. Let me stretch this out a little bit. So there we go. So this user in the middle rated this movie here, rated this movie here, and rated this movie here. There's also an overlapping relationship called likes movie. I was just playing with the database. But if I take a look at this rated here, check this out. I clicked on the relationship, and now I have a stars and a comment. I can click on the relationship here. Look at this. I just have stars, no comment. Remember I told you that it's flexible schema? I don't have to have a comment for every rating. And of course, I could click on a movie and see the details. And I can click on the user and see the details. So nodes and relationships may all have properties. Now, let's say that I wanted to know all the movies that David reviewed, and then I want to get the average rating for each. This is just showing some of the power of the query, and then we're going to go on to the mobile app. So let's take a look at this query. I'm going to match any movie that David rated. Then I'm going to squish together two queries. This is, I don't know what the equivalent in SQL is, but basically I'm taking the results of this, and that's what the with clause is. I'm passing on the movie title from the first query, and I'm renaming it to movie title. This is like an alias. And now I'm doing another query. This is all taking place on the server, so nothing is being chatty. Nothing is going back and forth between my desktop and the server. This is all happening on the server. First, I find the list of David's movie titles. Then I say, now I'm going to match for this movie title any rating. I don't even care who rated it. I just don't care. Not interested. All I want is this rating here, this R. Right? This is my whole world right here. And then I'm going to return the movie title and on-the-fly average of the value in stars. That's all I'm going to do. If I push this, here we go. It just went through and said, oh, David has rated these three movies over here. Wonderful. Now for each of those three movies, hit the database again for each of them, collect all of the rateds, and give me an average. I see the chat window blinking. Oh, we have a 2-minute break. Oh, okay, sorry, let me shut up for 2 minutes.
Ребят, приехала пицца, давайте возьмем и продолжим.
Okay, time to continue. enough about Neo4j. I wanted to show you that we have all this wonderful data in the database, and this online browser shows all of our goodies. Now, I wanted to build an application to be able to take advantage of this. Now, if we go back to a different version, I created another mobile service earlier today. Now, in order to do the kind of things I was doing with the movie reviews, let's take a look at what we were just working with. Sorry, let's look at our data. We had a to-do item table, and we had some scripts for insert, update, read, delete. That's really not anything we need for our movie database. That's kind of worthless to us. So I was playing around earlier. I wanted to show you that there's this tab called the API. Hopefully you can see it right here. And if you look at the API, you could have custom APIs. And I have one called Search Movie. If we take a look at it, there's some JavaScript in the back end here. And let's just take a quick look. How did it get there and what is it doing? Forget about this piece here. We're really interested in get. First thing, if you've ever used Node.js, they have modules. And here we say we require a module. Now, if you haven't, if you've never used Node.js, but you've used .NET, .NET has NuGet Packet Manager. And you can install package. Well, Node has the same thing. It's called the Node Package Manager, NPM. And you can do an NPM install of a package. NPM install package name. Very. So we need the driver for Neo4j. Then we point to the database, and then look at the query we're going to do. We're going to do some search on a movie and return its title. And here we go. We're passing to the Cypher query. These are all the queries that we saw before in the search window of the browser. Very similar. And then we're just returning a JSON object. There's really no magic. But it took magic to get this script up in the cloud. Because maybe there's other, we're leaving that. Maybe there's other APIs we want. So how did we do that? So one thing that I did, and I'll show you this, we had to enable version control. Built into, let's just go to the one we created together. Go to the dashboard. There's a little item in the corner called Setup Source Control.